Hello and welcome to today's video where we're going to do an introduction to polygons, and we're going to talk about how we classify them, and then we're going to go through some examples so you really see what these different types of polygons will look like. So what a polygon is, we'll start at the basics. It's just a two-dimensional closed figure that is the union of line segments in a plane. A polygon has three or more sides. So that sounds a little confusing, but if you take it just little bit by little bit, a two-dimensional figure that is the union of line segments in a plane. So that's just two line segments. If I have a line segment here, a line segment here, they have to be joint because it says the union of line segments. So maybe one here and maybe one here, and let's pretend this line is a little bit better like this, and they're all in one plane. That's kind of the outer sheet, if you will, and it has three or more sides. So this right here, this shape I drew, that's a polygon based on our definition. So that's all it is, and the easy way to think about it is just the shape. It's just any type of shape you have. It doesn't have to be one of these kind of perfect looking shapes like this square here. It can look a little more irregular like this, and you'll see some even weirder ones in a second as we go on. So now classifying polygons. The first step, there's really two steps. The first is it a regular polygon or an irregular polygon? This is a pretty simple thing to find out. It's regular if all the polygon's interior angles have equal measure and all side lengths are congruent. So all squares are considered regular polygons, and that's because all the angles, as you know, are 90 degrees and all the side lengths are congruent. So we give these little dashes here, and that makes it a regular polygon. An equilateral triangle is the same reason. All side lengths here are 60 degrees, that's 180 divided by 3, and then all side lengths are the same. So angles are 60 degrees, all the side lengths are equal, so that those are regular polygons. Then we get into irregular polygons, and these, as you can probably imagine, these are where the interior angles may be different measures and the sides may have different lengths. So as long as one of those two things is true, it's an irregular polygon. So even a rectangle where you would say, well, all the side lengths or all the angles are the same, they're all 90 degrees, right? But the side lengths are not. Those two are the same and those two are the same. They are not all four the same, so it is not a regular polygon. And this one is not this triangle is not a regular polygon either. And you can tell pretty quickly because the angles are different. You have a right angle and you have two other angles which are not right. So we know that it's not a regular polygon. So that's the first thing you need to figure out. You need to figure out is it regular or irregular. Pretty easy to determine that. Next is a little bit different. This is when we have the question of concave or convex. This should be a 2 here because this is the second part of classification. Convex is a polygon whose interior angles are all less than 180 degrees. And so all triangles and regular polygons are convex. So to be regular, you have to be convex. So regular implies convex. So if you have a triangle or a square or anything and you figure out, hey, well, this is regular, well, then you don't have to deal with this question. You know it's convex. So now, what does it mean that all the interior angles are less than 180? Well, that means that this angle is less than 180, this one's less than 180, and this one is too. And why is it true that all triangles have to be convex? Because a whole triangle has to be 180 degrees. So if I have sides connecting a triangle, so let's try to make an angle really big in a triangle like this and then this, it still can't be 180 because 180 would be a flat line, and then you can't have a triangle. You can't have three sides to a straight line. So there's no way for any type of triangle to be convex. But if you get to a bigger shape like a quadrilateral, you can have something that would be convex. And here with our square, we'll go through this example. All the angles are 90 degrees again, and so that means they're less than 180. So we're good. And concave. Now this is, you're probably used to convex figures. Those are the ones that you really see a lot of the time. They're the ones that you've probably worked with before. Concave is almost even hard to think about because it's a polygon whose interior angle includes one angle greater than 180 degrees. Remember that 180 degrees is the straight line. So this, the angle here, that is 180 degrees. So we have an angle bigger than a straight line. How does that work? Well, it works like this. Let's look at this shape here. Well, this one's not, this one isn't, this one isn't, and this one isn't. But this angle here, the one that is inside, it says all interior angles are less than 180 degrees. This one is greater than 180. It's greater than a straight line. While this one on the outside is a lot less than 180, but that's not the interior of the shape. My bad, I erased that there. That is outside of the shape, so that means that this shape is concave because it has that angle that is greater than 180 degrees. And this one is concave for a similar reason. This angle's good, this angle's good, this one's good, but then this one is greater than 180 degrees. It's a little bit steeper than a straight line. A straight line would be here, but this one is going up, so it's going to be over 180 degrees, and so that makes it a concave polygon. So now let's get into the classification. So when you're going through these examples, think 2 steps. Is it regular, irregular, and then is it convex or concave? So let's take a look at example 1. Okay, so we've got this quadrilateral here. I see that all the side lengths are equal. So my first question is it regular or irregular? So remember, regular means that all the side lengths are the same and all the angles are the same. I see all the side lengths are the same, that's quick, but the angles are not the same. These two are going to be equivalent, and then these two are going to be equivalent. So we put little 2 dashes there, and we'll put 1 here. So this means that it's irregular because not all the angles are the same, even though the sides are the same. This is a bit of a trick question. Irregular, and is it convex or concave? It is convex because all of these are under 180 degrees. And the best way to do that is just to look at them and see, is it greater than a straight line or less than a straight line? And the angles are less than a straight line, so convex. So like the official way would probably be an irregular convex quadrilateral. But we don't need to write that, just irregular and convex. That's the type of this polygon. All right, example 2. So here we have an example where all 4 sides are the same again. It's just, it looks like a parallelogram to me. Okay, well here we get 1, 2. I know those angles are going to be the same because that's the definition. That's how parallelograms are. But these again are going to be different. So again, we're going to have the same answer, irregular. And if you think about why it's going to be irregular, because even though the side lengths are the same, the angles are different again. So irregular and convex. Because again, none of the angles are greater than 180. So this is actually the same example as this. Basically, this one's just a little steeper. This one is. So these angles here are larger, but it's the same shape. They're both parallelograms. So now we have this weird looking shape. So weird looking shape, you should probably think this has a chance at being convex. So at least it's irregular because not all the angle measurements and the side lengths are the same, as you can see. So this is kind of the weird angle that we really need to pay attention to. That seems a little odd. So I first get that it's irregular because not all the side lengths are the same. And then now, is it concave or convex? This one's actually concave because this angle right here is greater than 180 degrees. So greater than 180 degrees. So that makes it concave. So hopefully this makes sense. Hopefully you kind of understand the 2 classification rules. So we have regular or irregular, and then you need to determine concave or convex. So thanks for watching, and let me know if you have any questions.